Mm. Good afternoon, students. Today we will discuss about the topics regarding the compiler design and the introduction topics. So the aim of our this session is we need to understand the different phases of the compiler, and we need to categorize the compiler tools also. So this is our aim. And here you can see that the objectives of this session is we need to describe the concept of the compilation, and we need to describe various phases of the compilation and different types of the compilation tools. Okay, so before going for the compiler, first we need to understand what is a translator. So suppose we all are having the mother tongues. Suppose my mother tongue is Telugu, so I can understand the Telugu language, but I can't understand other language. But so in order to understand other language, we need to have one translator, right? So as we are having the Google Translator, right, we are having Google Translator, which it will translate one language to another language, right? So same like that, the translator here in the computer, it will translate from one program, a program from one form to another form into another form. So that is a translator. So it will take one source program as an input and it will generate the target program in another language. So this is a translator. And if any while transforming from this source language to target language, then if any errors are there, then it will show you the error messages while translating. So that is a translator. So the input is here, suppose the input from one language to another language. So the Telugu language here is the source program, and suppose I want to convert this Telugu to Spanish. So this is a target program. So this is a general form, but as in the compiler design, so we can take it as a, suppose this is a source program like C, C++ or Java, any program, and you want to convert this high level language to the low level language, that is assembly language. Right? So this is a source program and this is a target program. So now we have understand what is a translator. So now we will look into what are the different types of translator we are having. So one is compiler, second one is interpreter, and third one is assembler, right? So our course is compiler design. So now you can understand that the compiler is a part of the translator. So that's why I have included the topic of translator. So now you can understand. So this is a type of the translator, right? So this will also convert from one language to another language, but we can see what language it will convert. And the same, the interpreter will also do the same thing, and the assembler also do the same thing. So these are the type of the translators, right? So it will convert the one form of the language to the another form. So these three will done the job from converting the source program to target program. Okay, now we will see what are the different types of, what the compiler will do, and what the interpreter will do, and what the assembler will do. So now first we will discuss about the compiler. So the compiler, you can see that it is a program, and it takes a program written in a source language and translates it into equivalent program into a target language, right? So it will take the source program as input and it will convert that into the target language. So it will take the high level language as a input. Okay, so it will take the high level language as input, and it will generate the low level language that is understood by the machine, and it will generate assembly language, or you can call it as a low level. What are the high level languages? The high level languages understood by the human beings. So now we understand the C level language, Java language, C++ language, we all understand those languages, right? So the languages that are understood by the humans, those are called high level languages, and the language that is understood by the computer, so that is known as the low level language. Okay, so the compiler will it will translate from high level language to low level language. So it will also do the same thing. It translates one form of the program to another form, but it will translate high level language to the low level language. And while transforming from while it translates to high level to low level, if any errors are there, then it will show you the errors here. Okay, now I think you understand what is a compiler will do, right? So here you can see that it will translate information from one representation to another. So here you are translating information. So generally the information is nothing but the program, right? So the program, it translates the program from one representation to another. Okay, so these are the examples of the typical compilers. You can see that the GCC, this is for used for C language, this is for Java language, right? And these are the Fortran and Pascal, these are the compilers. And the translators, you can see that O to PDF, PDF to PostScript, like we are translating one form to another form. This is a translator. The compiler is a type of the translator. So what it will do, it will convert the high level language to low level language, right? So for these examples, the GCC, Java, C, Fortran, Pascal, these are the examples for this one. So in this course, what we will study is the typical compilation is from, I already told you that, high level language to low level object code and mission code. Okay, so this is a typical compilation. It will transform from one high level source code will be given to the compiler, that is the input or the source program. Okay, and it will given to the compiler and it will generate the low level mission code, which is a low level or assembly language. Normally the mission, suppose you take one mission, a mission is constructed of zeros and ones. Now you are having zeros and ones, right? So zeros and ones. So the mission only understand in the form of zeros and ones. Now you are, by using compiler, you are converting the source program to the assembly language, right? So this assembly language is also not completely understood by the computer, because it also will contains the words, like it also contains the words like add, multiplication, for multiplication MUL, for move MOV, like that, right? But it is depend on the computer hardware. So the assembly language is dependent on the computer hardware, but we are not transforming entirely to the mission code, but we are transforming to the assembly language, and this should be changed to the mission code, which is in the zeros and ones. We will see which one it will come, which one this transformation will do by the assembler, and we will see that one later. Okay, now you can see this is a source program, and you know that this is a source program. You can see that integer expression, this is a function name, and these are the parameters you are giving to that function. Integer, some function you are doing, and you are returning this one, right? So this is a source code, you know. And in the source code, this is like human readability, because you are understanding that from here you can understand that here the one function is they are defining, and we are defining one variable in the form of integer, and we are storing the value in the D, and you can see we are calculating something, and we are returning the value to the function where it is called, right? So it is like human readable. Human readability is there in the source code, and it matches the human notations of the grammar, right? In the program we already see that the human grammar is there, we can understand. And you can see that name, constructs, and such as variables and procedures we are using. Procedures are nothing but the functions or methods, right? So this is a source code. Now we will go for the target one, assembly code. You can see that here it is also contains the words, but it is you can see that It is a machine instruction, consists of machine instructions. It is optimized by the computer hardware and it is a machine instruction.